Hi folks, so this is finding the area underneath a curve, so using integration. So if you look at the diagram here, so you have a curve, the red curve. So what integration does is it finds the area underneath the curve, so between whatever values you want. So here it's B and A. So any graph, if you put in a curve on it, so if I was to draw a curve, it could be any kind of a curve, or just do something like that. What integration does is it finds the area underneath it, or between it and the x-axis. So it finds underneath, or it would be the area here, so it's between the curve and the x-axis. Or you can use for the y-axis as well, but we'll focus on the x-axis for now. So if I wanted to find out what area there is between, you can find for between anything, okay, but we'll just say for maybe between 3 and 1. You can, what we do is we integrate it, whatever the curve is, you just integrate it and you put it between 3 and 1. So you just integrate whatever function that curve is, and then it's between 3 and 1. So it's just using definite integrals. So I'll just show an example here anyway. So here we have, it's the curve x squared minus 4, and we want to find out what's the area underneath it between 2 and 4 first, and then also between 1 and 2. Now you have to split it up here. You can't just do one integral between 4 and 1, and the reason is because when you do it underneath the x-axis, so when you're looking for an area underneath the x-axis, so down here, you'll get a negative answer because it's just that it's below the x-axis. So if I get the integral between 2 and 1, I'll get something negative. But if I was to add that to this up here, then this will be positive because it's above. So I won't get the total area. So what you have to do is you have to turn whatever this is, the bit below, positive first, and then add it on to what's above. So it's just figuring out how to set up the integrals anyway. So I'm going to be integrating that curve, so it's x squared minus 4 dx, because that's the curve. I'm just integrating that, and first I'm going to integrate it between 4 and 2, and that will find out. So I'm putting a 4 in there and a 2 there, and that will find me out that area then that I've shaded in by using that integral. So it's the curve x squared minus 4 between 4 and 2, and I'm integrating it. That will find out that area. To find out the other one then, like I said, I'm going to integrate it between 1 and 2. So from 1 to 2. But whatever I get there, I'm going to turn it into a positive. So it's between 1 and 2, and it's still the same curve because we're still using that curve, that red curve. It's x squared minus 4, and then you put in dx. So and you could, it's almost like you could almost put in absolute value signs there if you want, but you need to, as long as you understand that whatever we get for the second part, for this part, we're going to turn it positive. So then it's just using integration like before. So first part will be x cubed over 3 minus 4x, and that will be between 4 and 2, so just leave that in there, plus, and then it'll still be x cubed over 3 minus 4x, because it's the same thing we're integrating, but it's between 2 and 1. So I'm going to put in a 4 first, and then a 2, and then put in a 2 and a 1. So these will get pretty big quickly. So 4 cubed over 3 minus 4 times 4, minus, and then it's putting in a 2, so 2 cubed over 3 minus 4 times 2. Then plus, so it'll be 2 cubed over 3 minus 4 times 2, and minus, and it'll be 1 over 3 minus 4 times 1. So you can start to simplify this a little bit, or you could almost go and put each part into the calculator now. Just keep that part and the other part separate, because remember we said that the second part, whatever we get, we're going to turn it positive. So we get 8, well not 8, 64 over 3 minus 16 minus 8 over 3 plus 8, because minus minus becomes positive, and then plus in the middle. So then that will be 8 over 3 minus 8 minus 1 over 3 plus 4. Now when you put the second part, so when you put this into the calculator, you'll get a minus, like we said, so you actually get minus 5 over 3. So I'm going to take the absolute value of that, or just turn it positive, because it's the area that we found, so that will just become 5 over 3. And I'm just going to add that on then to whatever I get in the other part. So I'm getting 32 over 3 for that. So just adding those two together then, so you end up getting 37 over 3. So it'll be square units, because just to put it in that, because it's the area that we found. So we found the area then of all of the shaded bit there. Right, here's another question. So if you want to try this yourself, you can. If you want to pause the video and then play it on, and I'll go through the answer. But you'll have to this one a little bit different now. There's nothing to worry about underneath the x-axis, so we won't get something with minus that we have to turn positive like the one before. But the problem here is that if we just integrate below the curve, so if I just integrate below that curve, it'll find out all of the area. So it'll find out the area of the whole thing, but we don't want the area of the whole thing. We just want a little bit, this little bit in here. So what you have to do here is you have to integrate the curve first, and then that will find out the full bit, and then you have to integrate the bit underneath the line after. So just this little bit in here, and then you're gonna take one away from the other. So it will be the integral between, so we only have to look now between 3 and 1, so this bit here doesn't really matter at all. It's just that the curve continues on, so it'll all be between 3 and 1, because our shaded bit starts and ends. So between 3 and 1, it has to be minus x squared plus 5x minus 4. So we're going to integrate that dx, and then we're going to subtract the integral between 3 and 1 again of the line then of the x minus 1. And then that's gonna be it. So here, that's the area of all of it, of all of that, pretty much. And then this here is the area of the bit under the line, so of this bit here. So if you take those two things away from each other, it'll give you the area of the shaded bit that we want, that's missing. So then we just have to integrate it as normal, so it'll be minus x cubed over 3 plus 5x squared over 2 minus 4x, and that's between 3 and 1, and then subtract. So integral of this then will just be x squared over 2 minus x, or minus 1x, so between 3 and 1. And then put it into brackets as well. So you just have to sub everything in then, so it'll be minus 3 cubed over 3 plus 5 times 3 squared over 2 minus 4 3. Then subtract, so 1 in minus 5 times 1 squared over 2 minus 4 times 1. So that's on the first bit of it done then. Now, so minus, and then it'll be 3 squared. So 3 squared over 2 minus 3. And then we still have to subtract, putting in a 1, so 1 squared over 2 minus 1. So we can tidy it up a little bit, so that will be minus 27 over 3 plus, so 5 nines are 45 over 2 minus 12 plus 1 over 3 plus 5 over 2 minus 4, and then it'll be minus 9 over 2 plus 3, so just be careful with the minuses then, so minus minus, then it'll end up being plus 1 over 2, and it'll end up being minus 1, because the last bit is actually minus minus minus, so minus 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 gives you a plus. Sorry, minus 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 gives you minus. Now we should actually have a minus 5 over 2 in there, and we should have a plus 4 there. It's just minus, the minus outside the bracket above. We'll change it to a positive 4 and a minus 5 over 2. So that's a mistake. Now you could go to the calculator again straight away from here, or you can try simplify it a little bit more if you want, but what you should get in the end is 4 over 3 square units. And that's it then, that's it done. So that's the area underneath the curve but over the line pretty much. So that's it.